at the use of the PSL Wizard to take us through the measurement procedure in application of photophysiological safety standards. The PSL Wizard is launched from the desktop, and the first action we must perform is to select a new profile. It's recommended to save all of the profiles in the same folder where the measurements are to be performed. In that way, all of the information is held in one location. So we will perform this profile for the MR16 source. We can input all of the information as appropriate. This information will be exported to a template to produce a report in Word. I'm not particularly worried about these details in this case, but the principle is there. We can go to Next and select whether you want to apply IEC 62471 or EN 62471, having slightly different limits. And we also have application of the Artificial Optical Radiation Directive, the EU directive, which applies EN 62471, but actually allows cases of realistic exposure distance less than 200 millimeters effectively. JSC 7550 is the Japanese standard, which limits the infrared to 2.5 microns, and ANSI RP27, on which all of the standards were based. We will select EN 62471 since we are in Europe. We will take this MR16 as a non-GLS source in this case. The distinction between GLS and non-GLS has always been one which has led to much dispute. Here we will have more information in performing a non-GLS evaluation, since I can tell you presently that GLS sources in all cases will be exempt for all hazards. So non-GLS. Now we will use the profiler again to determine the size of the source and the location of the source. This is the procedure we looked at in a previous video. Firstly, we set the profiler, ensuring the iris in the front is open and the ND filter wheel is to the upper position to have no filters in front of the camera. We set the front edge of the profiler at 100 millimeters on the optical rail of the profiler and measure 200 millimeters from the front face, and in that location position our alignment aid. The profiler is out of focus, so we will adjust the position of the second lens in turning the rear screw on the profiler. And there we have the profiler imaging a plane 200 millimeters distant. At which plane we will now place the front surface of the MR16 source to be measured. And I will adjust somewhat the height to have it in view. Now, this source has a package which is somewhat diffusing. It is not really clear what the eye would image in the worst case where we want to view the source when on. But we will have a look at what we see on the screen. So we power the source on and we have clearly saturation. Then we will proceed to increase the ND filtering, first pushing the ND filter wheel down, so ND3 and ND4 still in saturation as indicated by the red light and the RGB bars, and still in saturation. We can try the next range down and we are well within level. We could try the previous range and try to desaturate to see what would result. It's always better to have as much signal as possible rather than being toward the noise floor of the camera. So we wait for this desaturation procedure to finish, which it has now. Okay. And we can try and slightly adjust the position of the sample. and see if, as I move the profiler, we get a better or worse focus. In fact, we can see really very little difference as we move to and fro. Some cases are really quite difficult to judge. It's simply a case of using one's own instinct. So we take this measurement as being that of the source. I again note that whilst the display here is somewhat asymmetric, this has no effect on the calculation. The reference distance to which we focused was 200 millimeters from the front face of the source. The reference reading, so we've set the profiler to 100 millimeters at the start, and since we haven't had to move it effectively to get the source into focus, so the plane of the front face is the same as that of the source, we leave this empty and we can calculate the dimensions and we can see the resulting X and Y dimensions. So again, the program records the image, finds the maximum signal, computes the 50% of that, and then the blue elastic band fits in the maximum source dimensions based on 50%, and finally 2 orthogonal dimensions are recorded, and here we have the result. So we can simply finish to continue the procedure. The next step is to select hazards. Now we can have a look back at measurement results. We have hindsight in this case. Normally you'd be going through this procedure and you select hazards before doing the measurements. In general, I would select certainly the first 3 hazards, actinic UV, near UV and blue light, because these effectively are taken account of in the irradiance measurement, the first measurement. Where retinal thermal measurements are required, one should go to the radiance configuration in all cases, and infrared eye and thermal skin require the infrared setup. The LED clearly does not emit any infrared, so I will not select those. The retinal thermal is a difficult one. In fact, the only retinal thermal hazards will be posed by lasers, for example, the sun or an arc lamp in direct viewing at 200 millimeters. All these cases are very unlikely, so in a sense one can automatically exclude retinal thermal. Where this is required, one can select it. Indeed, here it happens that we've measured an 11 milliradians field of view, so we have the data to analyze this. And we can go next. So, measurement distance, 200 millimeters. So from the front face of the source, our reference face, we have previously done this measurement, and we can load the irradiance of the MR16. It should be noted that these files shouldn't be opened in Bound Plus at the same time. Next, as we have seen in the irradiance analysis, blue light classification exceeds the exempt risk group, so we have to continue the procedure, go to the radiance setup. Now we select the load, and we load the radiance in 11 milliradians of the MR16. Next, and we have finished the procedure. In fact, the idea with this PSL profiler, PSL Wizard, is that one can interrupt the procedure. So one could have performed the irradiance scan and saved, and then performed measurements on another sample and then saved. So if they're taking calibrating the system once, performing a number of irradiance scans, and where required coming back in the radiance configuration, for example, to continue the procedure. We have performed the full amount, and we have an exempt, group 1, and exempt classification. A summary page shows you what has been selected. One can also obtain help for each page using the help key. Just of note that where measurements are performed in the infrared, an associated measurement of absolute irradiance up to 1100 nanometers is required, to which the relative spectrum measured in the infrared is attached to obtain an absolute measurement over the full spectral range. One can export to an IECEE report. This is the technical report for the IEC 62471 at present, with no EN amendments, or Word export, which is a simple template, and Word will take a moment to generate the report, which we will see shortly. The template of this report can be customized in that one can change the logo and some of the writing. In a moment I will show you the template as to what can be changed. We can see the details transferred which I've input, the source dimensions and the recommended labeling, the image of the source profile and the results. We can see, just out of note here, that the average angular subtense is 90.9 milliradians, so it's the average of the two angular subtense at two orthogonal dimensions. So it's 19.1 at 200 millimeters and 17.3 millimeters at 200 millimeters, the average of those two angles. The 90.9 is below the 100 milliradians of the blue light exempt risk group, and therefore no apertures were required in the measurement. And if we look in the users folder, public documents, Bentham, PSL Wizard, we will see template, and the template, of which there's one for use with the PSL profiler and one without. And we can see that the logo can be changed and some of the naming could be potentially changed, but the software is using a search function on these parameters, which must therefore not be changed. The laboratory details, etc., can be changed equally. Just to show very briefly the principle of when apertures are required, one can, should one wish, rather than using the profiler, input manually the dimensions of the source. So for example, if the source is very large and the view of the profiler is so small that you would have to move the source at a very large distance to see it entirely, which within the terms of the 62471 is not important, one can simply input the values. So if I put, I don't know, a fluorescent tube 100 mil by 50 millimeters and look at these hazards briefly, we can see that we have requirements of apertures. The UV and indeed the infrared eye should be performed in a field of view less than 1.4 radians, and that's to effectively account for the fact that the eye is protected by the structure of the nose and the bridge of the eye, etc. So any radiation outside the 1.4 radians or 80 degrees need not be considered. This aperture is calculated based upon 200 millimeters and 1.4 radians. And equally for blue light exempt risk group, we talked about before about 100 milliradians at 200 millimeters is a 20 millimeter aperture. So you'd effectively need to load two separate measurements. In practice, and although this may be slightly unnecessary, I tend to recommend simply doing the full measurement 200 to 1100, 200 to 1100 in all cases. And in that way, one need not have an innumerable number of custom wavelength files to ensure that we have the correct step size throughout the range, corresponding to that with which the system was calibrated. And that is the PSL Wizard.